Okay, this example is similar to the last one. It's just a little bit more difficult algebraically to find the answer. Okay, so we'll start the same way. We need to find critical numbers, so we're going to find the derivative first. Okay, so the derivative of this function is 2 minus. Okay, now if you're having trouble finding the derivative of this second part, remember that you can rewrite that as 3x to the 2/3. Okay, and so it's going to be 2 minus 2/3 times 3 is 2. X to the 2/3 minus 1 is negative 1/3. All right, and I probably, for this one, since I'm going to have to set this equal to 0 and figure out where it doesn't exist, I'm going to have to simplify and do some algebraic manipulation to this derivative first. Okay, so first I'm going to rewrite this as 2 minus 2 over the cube root of x. Okay, now one hint for problems like this is to go ahead and get a common denominator and make this a single fraction. That will make the process of finding the critical numbers a whole lot easier. So to get a common denominator, I'm going to multiply the first term by the cube root of x over the cube root of x. Okay, so then this is equivalent to 2 cube root of x minus 2 over cube root of x. All right, now I can go ahead and find the critical numbers because I have a single fraction. So to set the derivative equal to 0, since it's a fraction, it'll be where the top is equal to 0. So 2 cube root of x minus 2 equals 0, or 2 cube root of x equals 2. Cube root of x equals 1, and so that's where x is equal to 1. Okay, now I also need to figure out where the derivative doesn't exist. So since this is a fraction, the derivative doesn't exist when the denominator is equal to 0, and that's going to be when x is equal to 0. Okay, so here are my critical numbers, 0 and 1. Okay, so now I need to make a table. And in my table, I'm going to put the two endpoints, negative 1 and 3. And then both of these critical numbers are between negative 1 and 3. So I'll put both critical numbers into the table. Then I evaluate f of x for each of these x values. Okay, so I need f of negative 1. So 2 times negative 1 minus 3 times the cube root of negative 1 squared, or 1. So that's going to be negative 2 minus 3, or negative 5. Okay, f of 0 is 2 times 0 minus 3 times 0, that's 0. Okay, f of 1 is 2 times 1 minus 3 times 1 to any power is 1, so 2 minus 3, or negative 1. Okay, and f of 3 is 2 times 3 minus 3 times the cube root of 3 squared, or 9. Okay, so this one's a little bit tricky because without a calculator, you can't evaluate 6 minus 3 times the cube root of 9, but you can estimate and determine whether or not it will be larger than 0 or smaller than negative 5, because remember, all I need is to find the largest and the smallest y-coordinate. Right now it looks like it's these two right here. Okay, so the cube root of 8 is actually 2. So since the cube root of 8 is 2, the cube root of 9 is going to be slightly larger than 2. I'm just going to pick 2.1. I'm not sure exactly what it is, but I don't need to know exactly what it is. Okay, 3 times this is going to be 6 point something. It's going to be a little bit bigger than 6. If the cube root of 9 is a little bit bigger than 2, then 3 times the cube root of 9 is a little bit bigger than 6. So we've got 6 minus something that's a little bit bigger than 6. It's going to be negative, but it's going to be barely negative. In other words, it's just a little bit smaller than 0, and that's all I need to know. So this y-coordinate is 6 minus 3 cube root of 9. Okay, it's smaller than 0, so 0 is still going to be the absolute maximum, but it's not smaller than negative 5, so negative 5 is the absolute minimum. So I would say absolute maximum is 0. Absolute minimum is negative 5. Okay, now, I do want to say that if this number right here were the absolute maximum or the absolute minimum, you don't put an estimate with a decimal. I was just doing that so I could figure out about where this number was in order compared to these other numbers. I would write my answer as 6 minus 3 times the cube root of 9. Okay, if that were one of these, the absolute maximum or minimum, but it's not. Okay, if you want to see what the graph of this looks like, it looks like this right here. And so here is our point negative 1, negative 5, 0, 0. Here is our value at 1. I think that's 1, negative 1. And then here's the one we found just a second ago that was 3. And then 6 minus 3 cube root of 9. Okay, so we can see this is the absolute maximum over here, and right down here is the absolute minimum.